the lecture that I prepared for the introduction of the big data. This is, I think, this slide shows what we are going to discuss today. So today we are going to mostly discuss about what is the Hadoop and what is the Hadoop component, what is the ecosystem. This slide shows the overview of that, the software that we are going to discuss today. Probably after we finish the chapter 1, the introduction of the big data. Okay. So, last week we have talked about what is the big data, right? Big data means it's a big data, okay? The benefit of using such a big data is what? What is the benefit of using such a big data? Sometimes we can have valuable information or knowledge from such a big data, which is not possible in the structured data or small size such a data. Okay, so for example, we can apply something, the sensor information, sensor data for farming, and also we can use the crime history to predict the where, which area, which region is the serious, or the when there might be something higher crime comparing to other time, something like that. Like the predict police, the application using the LA Police Department, something like that. So, such a thing can be called as the nowadays data science. So we will take a look at briefly about what is the data science before we discuss about such a system that can manage and store the big data, which is a Hadoop. Okay, so data science actually comes from, it's kind of a different name of computer science. What is a computer science subject? It's something, is it really science? Yes, I think so. But anyway, the computer science deals with computer stuff. Okay, the computer architecture, operating system, database system, network, and so on. So that is a computer science. In other words, computer can deal with only structured information, data. So if we focus on the narrowing down such a scope of the computer science into the data, then we can say anything that deals with the data. Okay, any subject that need the computer power or computer processing can be understood as the data science. So data science nowadays everywhere. That is the reason you wanna study the computer science, then eventually you will get a job not only in the computer industry, but you can be part of a researcher, the genome research, or the DNA research, or the stem cell research, or you can use your computing knowledge for the computational biology, or archaeology, or everywhere, space science and the ocean, so anywhere. So that is the data science. That is the benefit of the data science. Okay. So nowadays we have the huge amount of data. Then why the data science are important? Because data science can deal with such a big data using the computer software. Eventually, so from the data we will get the more valuable information. That is called the data analytics. So that is the reason I named this course as not only just the big data system, but I add the data analytics. So that is our goal. That is the reason of the big data management. Okay. So these are the incomplete list of the from mine. Wait. So these are the incomplete list of the application that data science can be used, like the cancer detection in the health and science, and the user profiling. Okay. Through the web behavior, user profiling is nowadays very important for what? Marketing. So when you're running a small or medium-sized business, so you have the new product like the coffee, so ABC coffee. I'd like to have the marketing So how can you advertise your new item, new product? So traditional way is, so you have the experience to sell the coffee. So coffee, this coffee is very nice, the taste, and it has the fancy, the cup or something like that. So you target on the 20 to 30 age group, and especially for the lady who likes such a fancy drink, this coffee. So you know the answer. Then you try to find such a customer from your database, like the relational database or the marketing database. So you try to collect such a database that fit to that satisfied with your experience, your knowledge. Then advertise it. That is the traditional way. However, in the data science, using the user profile, which means you don't know who is whom. Okay, it's just in the social media data or internet. Then you collect all the information and try to guess whether user of this Facebook is in the 20 to 30, or whether this user likes my new product, coffee. Okay, how can we find? We can use something pattern mining. Pattern. So I have a history. Those who purchased this item and this item previously, then like the new item, something like that. If we can find such a purchasing pattern, then we can find those who already purchased the item 1, 2, 3 before, then focus on that one. Also, we'd like to analyze the Facebook data. From the Facebook message, we can easily guess sometimes whether this user is male or female, or whether this is old guy or young guy, or the children, or the 20 or 30 sometimes. So using the same idea, based on the same idea, they're using something pattern mining or the data analytics technique, we will guess which user is fit to our marketing target. Something like that. That is the user profiling, and says there are a lot. Okay, that can be used for the data science. Then, is it new one? No, it's not new one. We have used a lot of the similar thing. It's a similar thing in the business. Even nowadays, in this moment, even some of the courses in the School of Engineering, we are learning such a technique which is called business intelligence. So business intelligence is as I gave you the example. So business guy or sales guy or sales expertise or product expertise, they know the product very well. They know the customer very well. So they try to minimize the error and try to focus on the target, the marketing. Then from your existing database, you narrow down the data and do the marketing or sales the product. Okay, that is the traditional, typical business intelligence approach. Okay, which means you know the answer. Who likes this product? Or which target group will be our the customer for this product. You know the answer, you guess, at least you estimate. Okay? Then, based on that idea, knowledge, or experience, then you can utilize the database. That's the traditional business intelligence. Still used a lot and currently used. I don't mean. So business intelligence is old-fashioned or not accurate. Yes, that works very well sometimes, and that provide the reasonable benefit of your sales. What about the data science? Data science, sometimes you don't know who will be the target person. So 20, 30, 40, 50, it can be 70, who are young, the teenager. So region is a downtown area or suburb area. So you don't know. Just try to analyze. Just try to process the big data. You collect every information to sell your new product, coffee. So you collect the weather information, or you collect the some crime information, or something economic information. Any information, you collect everything. Then try to find the pattern. whether this group likes the new coffee or not. Sometimes you may not find the target group. Yeah, that's okay. Okay? So that is the data science. That is different from the business intelligence. Business intelligence, you know the target and then utilize using the benefit of the database, you can do the marketing and so on. On the other hand, the data science, you don't know the answer, you can just process the big data. Then from that big data, if you are lucky, you can find something pattern of processing the new product, something like that. Okay. These are the examples I'm going to give. So this is the kind of the example of the scenario, how the data scientist analyze the data. So collecting any data, the data, your system. So in our case, in this room, so we are going to discuss about the Hadoop as such a sandbox. So we put everything and try to understand such a data, then try to find the pattern from the data. At that time, we can use correlation analysis, or we can use the data mining technique. Nowadays, data mining techniques are used a lot, and also you can use the traditional statistical approach to analyze such a data. Okay, then one of the important aspect of the data science is predicting the data. The traditional data analytics, such as business intelligence, our main focus is to try to understand current data, current customer, like using average. What is the maximum? What is the minimum? What is the something? So current status, we try to understand. On the other hand, in the data science with the big data, is try to predict whether this user will purchase my item or not. Whether stock market is going up, going down, gain or lose, or whether there exists the power user in this internet group or in this social media data. So we try to predict. That is the difference. So predicting data is the most different thing comparing to the traditional data analytics. Okay. Also, so in other words, the job role of the data scientist is kind of discover, find such a pattern, such a knowledge, such a valuable information. So that is the main thing. However, the main, as we discussed in the last week, one of the main characteristics of the data is uncertainty. So in traditional data, it's a well data structure. Like you probably learned the data structure of the relational database model. Relational database model, you just collect the customer information that fit to the data model, like the name, customer ID, and address, age, and so on. So you know the answer is exactly fit to your design. Okay, then you try to query. That's satisfied with the condition. Who provide the condition? So business intelligence guy or the business analytics guy provide. It's a static data. Okay, it's a deterministic data. It's already there. But on the other hand, the big data and the data scientists deal with uncertainty data. We don't know whether there is the pattern in the big data, whether it's a valuable information. We try to what kind of patterns are there? No, we don't know. So we try to find such a pattern from the big data, which is uncertainty data. So spectrum of uncertainty is the not certainty or deterministic in the business intelligence is the more prediction and optimization problem of the uncertainty data. That's the difference. Sometimes it's hard to understand the difference between the uncertainty data and deterministic data, but while you are processing, while you are learning the big data, you eventually understand such a. Mostly it's the semi-structured or unstructured data. However, the business intelligence data is highly structured. For example, relational database model. If you took my course regarding to the advanced database design, as I said, relational database model is a very, very highly structured data. It's a very strong root. So we try to, sometimes the data doesn't fit to our model, but try to squeeze to make the data fit to our model. Otherwise, we cannot retrieve, we cannot query the data. Because of that, it's so fast, okay? It's so fast and it's reliable data. However, it's not easy. Yes, it is possible, but not easy to find certain pattern. Because that data fits to our model. Who designed the model? The data designer, business intelligence, already designed model, okay, based on the customer requirement. So, not very flexible. On the other hand, the data scientists deal with the big data. It's unstructured data. Yes.
Professor, I have a question
yes.
related to prediction. Like for the data mining, like techniques, if we apply the data mining techniques as you taught us last semester, we have ground truth to
yes.
apply. But for the prediction models, if we build a prediction model, how we can say that this prediction model is ready to go, and like, do we need to have like math model, like, or math proof in order to say this prediction model is okay, or we need to apply it and I don't know how.
So yeah, for example, in data mining, one of the popular data mining technique is a classification.
Yeah.
Okay, for example, supervised learning. Classification is we have a certain, for example, weather data. Okay, weather and school opening and canceled information. In this case, the temperature is 20 degrees and the snow is 10 inches and the wind speed is something, and campus is closed and open, closed, open, closed. Such as we have the historical data. So we have the last 20 years, it's around less than 1,000 the instances recorded. Then we use the half of that, okay, to classify whether today is the open or closed. So we train based on the decision tree. Each the attribute affect the open the campus or close, open or close. So we learn, we measure such an importance as a gain, okay, it's the entropy, for example. Then we have the certain this if the temperature is less than 30 degrees and snowfall is the higher than the 5 inches, then close. So we find such a pattern. Then we can predict. That is a prediction. When we have the new, so today we don't know whether it's open or not. Okay, then we try to predict using such a thing. So that is the one example how to use data mining for the prediction. Okay. Also, that is the example of the traditional data. What about the big data? Big data, we don't know whether snow affect, whether the temperature affect open and close the campus. We collect all as much information as possible, then try to find a similar pattern as the open and close. Then we realize for example, wind speed is more accurate. It's a similar pattern. The higher than, so if we can find such a pattern from the big data, that's without calculating the entropy or gain or whatever, you can just use such an information. Like the I will show you one of the example of such a thing, like the Google search. So we will see such an example a little bit later. Okay, that is a kind of example of the prediction. Okay. So nowadays, I know that many of the students are interested in such a big data expertise. Who are the data scientists? What kind of skill do you need to be a data scientist? Almost everything, right? So I believe that among them, the most important part is the something math. Okay, that's the basic. That is the reason we have learned that no matter what kind of job you get, in your elementary school, middle school, and high school, you learn the math a lot due to the importance of the math. It's the same thing in data scientists. As I introduced, data science is kind of computer science. It's a different name of the computer science. Computer science comes from the mathematics. Okay, still many of the computer science program is under math department. In addition to that, so definitely you should be expertise on data. You should know. If you do not know the data, there's no way to analyze. Okay? As if the computer science student in computer science department, you should know the data. Okay? Which means it's a data structure. So that is the reason in your project 1 is 1. First thing is data. You need to find the data, especially potentially big data, okay, not small data, just 10 instances or the student information in this room. No, so potentially big data. Okay, why don't you try to find such a data, big data. Okay, then some other skills are needed. Also nowadays the visualization is getting focused on. So visualization is one of the area of data analytics. Okay, what is it? Some of the examples throughout the semester. So, however, if you are taking the course in the technical management, probably you will learn about such a BI, business intelligence-based data analytics. But even though the data scientist looks like the fancy and nice, in the company, they still need the business intelligence as well as the big data. That is true. Okay? So, wrapping up, that is called data analytics nowadays. If we use the big data as a data scientist, that will be data analytics. So, what is a big data analytics? I will show you the example of this one. Somebody already know. I need to connect the internet first.
Welcome to Google Flu Trends. Today we're going to show you how Google Flu Trends works. Google Flu Trends uses aggregated search data to estimate flu activity in near real time. Millions of people search for health information online. As you can imagine, there are more flu-related searches during flu season, and we found that certain search terms are good indicators
Actually,
of
they
actual
just
flu
count
activity.
number of queries, search, Google search. That includes flu. That's it. Then we can predict whether
past 5 years flu seasons
the
like
flu
this.
season or not. Whether this
We
area
then look
is
at the
the
popularity
output
of individual
of
search
the
queries
flu.
over this time period.
Very simple.
Using this method, we identified search queries that matched well with CDC's data. Google Flu Trends is
We don't have
updated
to be
in
expertise on
time.
flu.
For
Whether
instance,
temperature
on
is
this date,
higher than
Google Flu
100
Trends detected
degrees
a
or
significant
the
increase in
whatever.
flu
No,
activity.
we don't have to just
CDC
count
reported
number
the
of
same
Google
increase
search.
2 weeks
Then we
later.
can decide whether this is the flu
For
season.
some
Whether
countries,
this
like
area
Mexico, we don't have
is
official historical
critical
data to
for
work
the
with.
flu.
Instead, we look for
We can
flu-related
use
search
the
queries that appear on a
visualization.
seasonal
We can
curve.
just map
Since
to
these
the
estimates have
using
not
Google
been
Map.
compared with
We
official
can
historic flu
the
data, we
Google
label them
Google Map.
experimental. Personal search data remains safe and private. We do not use personal
We
health
don't use
or
any
personally
patient
identifiable data
information.
to
Probably
create our
long time ago CDC used the
Our
number of
graphs are
patients
produced by an
who
automated
visited
format that looks at aggregated
the
data from
doctor's
millions of
office,
searches done
but
over time.
at the time the age is 10 or the female was, we don't need to decide such a thing.
Google Flu Trends complements existing flu
Nowadays the
surveillance
CDC
tools.
also use
Earlier
such a
detection
Google
of flu
Trend.
activity enables public health officials and the public to make more informed
By the way, the
decisions.
CDC is the
For
Center for
official
Disease
information about flu
Center
activity,
in United
prevention,
States.
and treatment, please visit your national or local health
You
resource.
can see easily the
Check out Google
Scandinavian
Flu Trends.
that is Norway. Well, so you can see the different colors. So that is the blue area. So this is a good example of how to predict the data using big data. Right? Comparing to the traditional approach, in the traditional approach, the experts get together, then discuss about the patient, 1 case, patient 2 case, patient 3 case. There are more than 10 cases, high fever, and so we will decide that this is a flu season. But we don't have to do that. By counting the number of query, by region or by country, so we can easily decide the predict the flu season. So, which means our paradigm is changed. So it was the hypothesis-driven science or analytics, which means I have the idea to decide the flu season. Flu season, the flu means at least 10 patient cases for each region or state who have the over 100 degree the fever and the temperature and what else? Something symptom, detect the symptom, then we will determine this one. So that's the hypothesis. Then test with the previous data, whether that fit. If yes, then CDC announced that this is the rule to determine the flu. So that is a hypothesis-based approach. But nowadays it's a data-driven. We don't know. We don't care. We don't have to worry about the privacy or the other info. Just count, just analyze the data itself, especially big data. Then we can solve a lot of problems. Also, we can apply something visualization for easy understanding, for better understanding the data. One of the important issues of such a data, big data, is social media data. So I believe that many of you guys will select the social media data for your project. That is true. There are a lot of types of the social media data. So some of them I use, I've never seen this. The others, like LinkedIn, Facebook, are very popular in general, but sometimes we have very domain-specific the social media data, and this social media data is actually the big source of the big data analytics. Okay, so this slide shows the comparison between the traditional data analytics versus the big data analytics. So in the traditional analytics, the experts get together and decide this is the problem. Okay, which means that this new product will be attractive to the 20 to 30 years of age, especially for the female, something like that. Then ask to the IT department or database, the expertise. Then see the result. On the other hand, the big data analytics, we don't care the data itself, just collect all the data, then analyze it and ask the business guy, business intelligence or the data analytics guy, whether this is okay or not. So, for example, from the data, we don't use all the data, just focus on or structured data. Okay, minimize, narrow down, then find the target customer, something like that. But in big data analytics, we use all the data as it is. Then try to find the pattern. Then such analyze data whether they fit to the other comparison. But because we analyze all the data, we use all the information as it is. So this is a hypothesis-based approach, but right now it's a data-driven approach. Okay. Also, one of the benefits of using such a big data is it's keep changing, so it's called the streaming data we can handle. Like think about the system log data. Each computer has the log data. So if we analyze such a log information, we will detect whether this is a fraud, whether this is a hacker's attack, whether this is normal, the request. The data are, we receiving the data, the even at this time, then we process such a even the current data. So what will be the future of such a big data? Recently, I read a book. It's a Datanism. It's authored by the Steve Lower in the New York Times, the publisher. Everything is data. Something is Datanism. So if you have a time right now, it's just it's not the IT book. It's just for general purpose. You can, if you do not have any background in the IT or the computer, it's a good the introduction book to understand the big data. What if economics? Do you know the invisible hand? What is the invisible hand in the economics? So in the market, it's automatically so adjust supplier and consumer. Then the price will be the adjusted, something like that. It's the invisible hand. What is the invisible hand? I guess data may be such an invisible hand. Okay? There's no one who determines the price is automatically adjusted, but who that invisible hand may come from such a big data. Okay? So that's the, however, this Datanomics actually the name of company, so I cannot find any specific. Also politics. What is a democracy? Democracy, we can vote for our decision, like the leader, president. But how many times? Not every time. So sometimes we believe the politics, so we cannot do the political action every time. Instead, we select the politician. Then on behalf of me, politician is doing the something political action. That is the democracy nowadays. However, if we can have something such a big data on a big data system, like each and every one has the something sensor. So whenever the governor or the president need to decide whether we are going to have a holiday next Monday, then vote every time. Every time we vote, then decide. Or so we can use such a data analytics for the pilot. I'm not sure whether that is good or not. By the way, next Monday is a holiday. Fortunately, we do not have the class. Those who are very new in the United States, the first week of Monday is always a holiday in September. It's Labor Day. Okay.